Good morning to all. So, we will continue the same topic, that is the basic processing unit, where we are basically describing the basic steps happen, what are the basic steps involved while executing an instruction. Okay. And what is the objective? Objective to learn that what are the signal required for those basic steps. In last class we stop at a point that what are the micro step I will tell required for executing an instruction. Okay. So, we will start that point and we will see if there is a jump instruction, how this happen, and then we will say is once basic is done, then we will see there are two design principle for control unit design. One is called hardware, another is called micro control program. So, we will cover the second part. Hardware part actually I will be teaching from some other book called Hayes. So, as I said that you need to remember this structure always. So, for anything what are the steps required for executing a particular instruction, this is a very essential thing, as you have also noticed in last day's class. Executing a complete instruction, we have the instruction that which running example is add R3 comma R1. As you know that R3 within bracket indicates basically the memory location. So, you need to fetch the operand from the memory location and then you add and store the result R1. For that we learn these are the basic step. These are the basic step, how we conclude these steps are correct. So, here is the instruction we need to do. First step is you have to fetch the instruction. Fetching instructions are there in the main memory. So, that needs to be brought to CPU. So, therefore, program counter, as I said, when you press ./a.out. So, that will give you the starting location of the program. So, let us say this is the first instruction in the program. So, program counter will be loaded the starting location, let us say 2000. So, therefore, what we need to add this location 2000, the instruction is here, that is add R3 comma R1. So, the program counter contain the value 2000. Okay. So, that should be loaded here. So, therefore, MAR in is 1, PC out, because this value only will come, and then we have to issue the read signal, and then we add select 4 and then Z in. Why? Because program counter value will be incremented by 4, because that is word length is 4. So, therefore, this same value we want to add bring 4 here, and this 2000 will come here, and then we want to add and result will be stored into 2004. So, in the next step what will happen, program counter value will change. During execution of the an instruction, program counter value will change. So, therefore, this Z out will be PC in, and this value is responsible for if there is any jump instruction. Okay. And then it will wait for memory function complete, and then when data is available to MDR, so that value it should be MDR out, and it will store in the register called IR in. So, now instruction is there, program counter value changed to 2004, and these three steps are same for any kind of instruction. So, now in decoding it will change, because if it is a jump instruction it will be different, if it is not jump instruction. So, as for this is not a jump instruction. So, then what we have to do? So, R3 out, why R3 out? Because you have to bring the data from the memory, and that should be stored in MAR. So, that is why R3 out to MAR, and then it will issue the read signal. In the meantime, someone asked in the last key, see you may not do this part here, then it will be delay further, and this time actually that CPU was idle. So, it is better to use that part when working with for waiting for the data to come. Within this time internal work can be done. So, that is the thing is R1 out, because that value needs to be added. So, it is coming here. So, through this line, so value of R1 will come here, and while it is available that MDR will come this line, and then we will issue the signal that add. So, it will be added, and result will be stored to R1. So, question is whether that value of Z in will transfer to other register in a single clock cycle. Yes, it will be transferred in the single clock cycle. So, all operation here will be done in a single clock cycle, all operation here it will be done in a single clock cycle. See, this all operation means this operation, this operation, this operation, this one, input A and B, this one, this one. This is a name, this point name is A, this point name is B, that is all. This is a connection name. We gave a name called connection to distinguish there are two connections. One is B is directly connected with internal bus, whereas A point is connected through mask and then register Y. To distinguish there are two input to the ALU, but we are giving two different name to distinguish one from another. And now if it is a jump instruction, how it will change? Jump instruction means program counter value will change, program counter sequence will change. So, after decoding, after fetch is remain same, after decoding it will realize that it is a jump instruction. So, program counter value immediately needs to be changed. So, how it will realize? After decoding means after here, this is the instruction decoder. From here output it will take the, it will tell that this is the offset where to jump, and then it will be added with the program counter present value. So, program counter present value is here. Instead of bringing for here, bringing from program counter, what we did it? We loaded yi here. So, that is the yi is already here, and then this offset will come here, then yi will come here, and then you just simply add these two offset and the incremented program counter value. That is for the conditional jump we talked in the last class. So, these first three steps are remain same. So, here is offset field of the IR, that means after decoding it will realize that it is a jump instruction, and what is the offset means where to jump. As I said in the last class, let us say, so location is let us say 2000, jump instruction 2050. So, what is the next instruction address? So, 2004. So, then offset will be 46, or it can be here also, it can be, so let us say 1000 also. So, this is 2004 and then we have to go to 1000. So, in that case what will happen? That 96 minus 96 will be the, so 1004, right. So, it will be minus 1004. So, that will be the offset. So, whatever the program counter, so that will be added. So, and program counter we are passing through yi in. Okay. So, that is the offset field, it will be add z in, okay, and then it will select y, and after it is done. So, it will be program counter value will change. So, therefore, PC in and z out, whatever the value z out, so it will be added here, and then that is the end of the instruction, because now program counter value is loaded. Now, it is a new instruction, new instruction will start again executing. So, again this is, this three step will be continuing. So, this is for jump instruction. So, this is for conditional jump. Now, sorry, this is for unconditional jump, and if it is conditional jump means what? So, it will check whether the value is reached at a particular point, then only it will jump, otherwise it will not jump. Let us say we are checking the value, it will, let us say this location 2000 we have branch less than 0, then you jump say to some location, let us say 1000, and then you say DCR R2 like earlier, okay, and then you jump location is 1000. Did you understand this loop? Actually, you started a point, I think I talked in the earlier class in pipeline. So, this is a loop, you start writing the code here, and then decrement R2 and then branch less than 0. If it is negative, then you jump, otherwise it will be sequential, next instruction will be executed. Actually, what happened, for any operation there will be a status bit. Okay. So, status bit means, so there will be a special register is called the PSW, program status word. So, program status word has say let us say 7 to 8 bits. So, if the result is 0, so that is something called Z bit, it will be 1. If the result is negative, so this is a negative bit, so that will be 1. If results remain positive, so let us say this is a positive bit, this will be 1, otherwise it will remain 0. So, after this operation if it is really negative, so then what will happen? If it remains negative, then it will jump. Okay. So, that means negative bit is 1, then it will jump, otherwise it will not jump. Okay. So, it will check whether the negative bit is on or not. So, here actually one more condition will be added, ki whether negative bit, if it will jump only if negative bit is there or negative bit is 1 or not. So, if we started with very simple architecture, that is only one bus you had. Now, if you have a multiple bus, like instead of one bus if you have a multiple bus, so that will be more complex, okay, and we do not have time. So, therefore, we have to skip. So, multiple bus organization advantage, earlier we had 7 steps, now it will be reducing because you can do the parallel operation. Here we will be talking about microprogrammed control. So, we had the basic background, now we will see how the control unit can be designed. So, earlier what we learned ki R in equal to 1, okay. So, that should be activated. So, one signal should be there. So, if you have a register here and then you have a connection here, let us say then this is in, this is out, what basically you have to do, this point should be 1. So, this is the signal, or this point should be 1. That is we want, that is we want. Let us say here it was PC out comma MAR in, okay, and then what then next is read. So, read is also a signal. So, this should be 1, this should be 1, this should be 1 in the first step. So, we should design control unit in such a way that in the first step of any instruction, so these all signals should be 1. So, that is the control, that is the task of the control unit, because these are the signal we want should be activated at the first step of the each instruction. So, what can be done is like for generating the control signal also we can use the style of the programming. You assume that first step, then you complete the second step, then you complete the third step and so on. So, it is like you are writing the code and then it is getting executed. So, if we follow this model, then that is something called microprogrammed control. For generating the control signal, we will use the programming model. Okay. So, it will be clear later also. So, there are some terms, that is control word, micro routine, micro instruction. So, this is actually for let us say one instruction. It has 4 steps for executing one instruction, as we have seen that we had 7 subtasks, okay, that 7 steps. What we do it ideally, in the first step we want that PC out should be 1 and we want MAR in should be 1, read signal will be 1 and YR and select signal should be 1, add should be 1, Z in should be 1 and rest all will be 0. What we do it, whatever the all signal available we put on, say let us say in column, and first step what we do it, we put 0 whenever it is not required, otherwise if it is required, so we put 1. Similarly, second step, what are the things required, we put 1, rest will be 0. Now, what do you do it, control unit should read one after another, and wherever is 1 is there, so it will activate, and wherever is 0 it will not deactivate, it will it will not do anything. So, therefore, we will have a control unit. What control unit? It is nothing but reading from a memory one after another. So, in the first step it says you put PC out, so let us say this is all our signal, PC in is a line, PC out is another line and so on. It is like you have a something here, so you have one is PC in, another is PC out and so on, this all are whatever the all signal available you put here, and then when it is required it put 1, and then what you do it, for any instruction that first step you read this one, for next step you read this one and so on. So, if the machine has 256 instruction, so it should be that 256 different sequence of and 256 micro routine. So, what we say is sequence of step we say will form a program. Here we will say is the micro program, or we will say the micro routine. So, this is nothing but a micro routine, and this is something called micro instruction, and this entirely is called the control word. Control word consists of 0 and 1. This is basically if it is not activated 0, other it is 1. So, control signals are generated by a program similar to machine language program. So, when we write a program, then it will convert to the instruction, and then what we learn ki instruction will be executed one by one, it will fetch, decode and so on. Similarly, here is instruction is already for this add R1, R3, instruction is already there. What will be the sequence that is also stored before that, and what will be done ki what are the signal needs to be activated. Simply the control unit should have a facilities that it will read those, it will read from the memory and then it will be placed. So, in other way around that those line will be activated, rest will be 0. So, that is the main idea of the microprogram control. So, that means it should read one after one. So, after reading this part, next it will go what happened in while executing a program. So, program counter will be incremented one by one to get the next instruction. So, here also should have a program counter to distinguish between original program counter, we will say is the microprogram counter, that will be there within the control unit. Okay. So, here you see this is the case here that we learned. So, we have 7 steps for the instruction, and in the first step PC out should be 1, MAR should be 1, read, select 4, add, Z in. So, this signal will be 1, rest will be 0. So, therefore, in the control word, see all signal you keep PC out, this and Z in, all signal is there, only this part will be activated. So, in the memory, so let us say for this signal that location will be there, not memory means it is not memory in RAM, it is within the control unit. So, till now what we learned ki instruction will come to the instruction register. So, from instruction register it will go to the decoder. So, it will realize that which instruction it is. So, after realizing it is add instruction, add R1, R3 or R3, R1, it will realize it is add instruction which involve the register R3 and R1. So, it will go to the starting location of this instruction. This instruction means this instruction corresponding what is called the micro routine is stored in a memory location within the control unit. So, it will go to that location and then it will sequentially execute. So, what will happen? There is a micro program counter. So, it will increment one by one and then it will generate the control word, and that control word will be executed. That it is control word is nothing but the say let us say which line should be 1 and which should be 0. In normal program what we do it will run sequentially. Okay. So, here also it will go one by one. So, therefore, we need the micro program counter. So, it will increment what should be the next control word. So, it will give the control store is nothing but all instructions corresponding micro routines are stored. For each instruction we will have a micro routine. For add R3, R1 it has micro routine with 7 control word, because each that step represent a control word. So, it is stored in the control store, means control memory, and then it will represent the control word is basically nothing but the signal add should be 1, PC out should be 1 and so on. So, it will tell that once it is complete. So, next program counter value, micro program counter value will be incremented and so on. So, question was what is the difference between control word and micro instruction. Here this is I said the control word. So, this step is also a micro instruction, entire machine instruction, and then each step is called micro instruction. Otherwise, you can say this is the micro instruction and then corresponding consisting the values 0 and 1 is the control word. So, it is very close, or you can say it is the same. Now, if there is a branch instruction, because earlier what we said ki it will go sequentially, and if you carefully see there is an instruction called end also, that means that is the end of the instruction. Earlier it was also there here. So, end is also an instruction, it is also a signal, and if you see carefully there should be end also here, yeah, the end is also there. So, end is 1 at the same step here, end is 1, all other cases it is 0. Now, if there is a branch instruction, its life is not so smooth, because jump instruction means program counter value changes we have seen earlier. So, here also something will happen. So, program is executing with micro instruction is getting executed, that will change. So, then what will happen? So, after this part will remain same, there is no change, first 3 steps, because that is the fetching the instruction. After decoding only this control unit, this part will come, because if you see here, so diagram after IR, so before is remain same, that 3 steps remain same. After IR it will realize which instruction, and then it will go to the micro routine of that particular starting location of that that micro routine. So, now if it is jump instruction, what will happen? So, you have to go to the that corresponding jump instruction. So, here we go. So, it is branched to the starting address of the appropriate micro routine. So, now if n is 0, then it will branch to the micro instruction 0, otherwise it will continue. Why it is so? Say, let us say here branch to the starting address of the appropriate micro routine. So, it realized that jump 2050, no, it is a conditional. So, let us say jump, it will jump if, okay, here is something you can, if it is negative, then you go 1000. Let us say this is the conditional jump. Then what you have to do it? You have to check the value. So, in earlier case, if it is conditional or unconditional, there is no need for checking. So, therefore, status bit, that PWS you need to check, program status word you need to check, and corresponding jump instructions also will have the micro routine, and let it stored in the control memory at the location 25. So, there should be a instruction, it will check the value of the PWS program status word, PSW program status word, what is the bit n, whether it is a negative number is 1, if it is not a negative number, then you branch to the micro routine 0. So, then it is a next instruction, and the next instruction means what? Again it will you fetch the instruction. Fetching is same for the first 3 steps are remain same for each instruction. And if it is 1, if it is negative, then you branch, that was the condition. Then what you do it? Now the same thing you do, what? That offset you add, and then you move to the first part. So, you add the offset, select 1, add Z in, and then this one. Now, program counter is actually changed, and it is same thing, again you fetch the instruction. What I said, if there is a conditional branch means what? Conditional branch means you have to check the results. If the results is something, then only you do it, otherwise do not do. So, this is the, let us say if there is a negative, then only branch. Before that there is some DCR, some values is there. So, before operation, if the program status word change and the negative is 1, negative in 1 means actually negative, less than 0 results, then only you jump, otherwise you go to the next instruction. So, that is the story. Now, what you do it? First part is executed, you do not know, it is a fetch instruction. So, it will go as usual. Now, what will happen? Next, after decoding, you realize it is a branch instruction, and branch instruction is stored in a location in the control unit at the location 25. So, basically this branch instruction is checking whether the results, that negative bit is 1 or not. If negative bit is 0, that means it will not jump. So, if it is not jump, that means if it does not jump means it will go sequentially. So, therefore, if no jump, then there is no need for changing the original program counter. Similarly, here if there is no need for changing the micro program counter. So, therefore, what it will do? It will jump to the micro routine 0. So, because it is a new instruction, because it is the next instruction and that is the new instruction. So, it will go sequentially. In the original also it will go sequentially. So, here it will go. Now, thing is that if it is a branch instruction, originally what you should do? Now, branch instruction, if it is a branch instruction, then program counter value will change. So, therefore, you have to change the program counter value. So, they had how do you change that we learn is program counter value will be changed like that, select y, add and z in. So, here select y was not there in the slide, but you have to add select y. If you go back here, select y you have to add. So, we are talking about here. So, now program counter value will change here. So, here micro program counter value will change and then it will start the new instruction.